In the first part of section 6.4, we're going to talk about rational exponents. Rewriting rational exponents. In the first half of this chapter, we took a look at something like this. So the cubed root of 216. So to start off this unit, we want to be able to see that writing the cubed root of 216 could be rewritten as 216 to the 1/3 power. Similarly, if we had the expression 5n to the 3/2 power, you could rewrite that as 5n cubed square root. So the overall concept here is that a to the m over n power could be rewritten as a to the mth power taken to the nth root. And you could also rewrite it with like the nth root of a in parentheses too. It would give you the same thing. So for example, if I wanted to simplify the 4th root of 2k to the 5th power in exponential form, I would rewrite that as 2k taken to the 5th power and then divided by 4 to represent the 4th root. So the last thing we'll talk about in this video is properties of rational exponents. The first one we've already seen, a to the m times a to the n. When I multiply expressions together, I add their exponents. So for example, if I had x to the 2/3 power times x to the 5/3 power, I would add those fractions together, and I would be left with x to the 7/3 power. Next, a newer concept that we're going to look at, a to the m taken to the nth power. When I'm taking an exponent to a power, I multiply them together. So that's the big difference between that last example and this example that we're looking at. So now, if I had x to the 5/4 power taken to the 1/4 power, I'm going to multiply those fractions together, and I would get x to the 5/16 power. Finally, if I had two expressions in parentheses taken to the mth power, I would take like both parts of that expression and take that to the same power. So if I had x to the 5/3 times y to the 1/3 power, and then that whole thing taken to the second power, I'm going to multiply 5/3 and 1/3, and it would look like this. X to the 10/3 times y to the 2/3 power.